Hi, hello guys. My name is Godwin Abogoye from the Department of Urban and Regional Planning. And on this tutorial, we're going to be discussing on quantitative techniques in planning. Under the quantitative techniques in planning, it is ANOVA we're going to be treating as the topic for today. So, I don't have a board right here, but I'll be treating on this foolscap right here. So, I want you guys to stay tuned and pay attention to little details. Don't miss anything out. So, let's try this and see. Come on. Alright guys, so we are starting on ANOVA, in which ANOVA, it is said to be analysis of variance, is a statistical tool used for comparison of serial treatment, means at detecting differences among serial population means. Okay, the assumption for this ANOVA is one, we can say sample from each of their population must be independent and random. Their population must be normally distributed with the mean Ni, which is stated as the alternative, not necessarily equal, and equal variance. So there are three types of variation, and this variation is said to be one, which we have sum of squared total. Which the sum of square total formula, it is said to be summation x raised to power 2 this minus common factor. This is for the sum of square total. And the second one is sum of square treatment. In which the sum of square treatment is said to be the summation of y raised to power 2 all over n minus the common factor. That is for the third part of the variance. The number 3 is equals says it is the sum of square error, which is the sum of square error, which is sum of square total minus sum of square treatment. That's for the number 3. So, in carrying out this computation right here, we have to use a particular formula in carrying out the computation. And this formula will now be turned into the next page, because so I'll be flipping this sheet over to the next page so that we can continue. On the next page, what I'll be showing you is the direct formula in which you will place all these variants after getting them in all total. So let's go to the next page right now. So now we are in the next empty blank space. Now the formula goes like this. Okay, so here we say source of variance, source of variation. Here we say sum of square. We say direct factors and mean of square and F value, the F value. This is a constant formula in carrying out a computation on ANOVA. So let's start here first, between sample treatment. Between sample treatment. Sum of square in between sample treatment is SSTR. Okay? The direct factors is rho minus 1. It is constant. It is constant. To get your mean of square on this formula is SSTR divided by R and rho minus 1, which have its own constant figure. So now we come down to the next phase here, which here we say within within sample error, right? Within sample error, where we have SSE. And within sample error, it is number, that is the total number, minus rule. That is to get the direct factor. Now, to get your mean of square, now we're doing the same thing. Sum of square error divided by number minus rule. That is how to get your mean of square. So we now go further to find our between sample treatment, between sample total, sorry. Or let's just indicate it as total in figure. So that is how the formula is. Let's say total. That is for sample total. Don't sum of square total. Don't forget. Now, the F value, which is MSTR divided by MSE. That is to get your F value. So let's go further by our total, sum of square total. The sum of square total is SST. And the direct factor is number minus 1. This number, it means the total number minus 1. That is to get your direct factor. So let's go further in computing our question. Let's go back to the other page of this slip and read our question that has been set for us to solve it. So let's go. Okay, right here on this question, we have the question being set out. They say, okay, here they say 4 different types of fertilizer were applied in the cultivation of akeha, and the yield obtained are as shown below. Use ANOVA to test if the fertilizer are equal, effective or not. Use A equals to 5% level. This 5% level is testing if the fertilizer are equal, effective. So in my next tutorial, where I will be talking about the normal distribution, where the 5% test and the 1% test, if it's to be accepted or rejected, we will know about that. But let's come back to these tutorials. So on this question now, this is the variance given to us, the total numbers. What are we going to do? First things first, we will first solve for the sum of square total. Solving for the sum of square total now, we'll go back and say, let's go back and say this. We are going to pick all this and square them all up, one after the other. All of this and square them all up. So I'll be flipping next to the next page and start to sum them all up one after another. So let's go back to the next page. In case the video is confusing, you can take it back and you can rewind this video and get clarity on this, right? All right, let's go. So solution. Calculating for the sum of square total. Now, SST is equals to summation of this x raised to power this raised to power 2 minus the common factor. Now, the summation of this raised to power 2. What are we going to do? I said the summation of all those figures, all those numbers in the rule. I'll start by saying is equals to summation x raised to power 2 is equals to 64, which are in the rule, raised to 64 square plus 78 square plus 75 square plus 55 square plus, that is how you're going to get all the numbers, plus them all up. When you get the square, 59 square plus 77 square plus 76 square plus 68 square. So when squaring all these numbers that are given to you as the variance, you get in the total number, which I already have my total number. The total number is equals to 100 134,000. No, 134,192. Okay, 134,192. Calculating this have to be carefully calculated. You have to take it slowly in order to avoid mistakes. So 134,192. That is for the sum of square total. Now we'll move to the next and say for the sum of square treatment, which is SSTR, equals to summation of this y raised to power 2 minus common factor. Okay. Oh, sorry guys, we're not done with this. Let me keep this aside. Now after squaring all this up, you now say minus the common factor, right? Minus the common factor. How to get your common factor now? It is very, very much important in knowing how to get your common factor. Getting your common factor goes like this. The grand total divided by n. Let's go back and look for our grand total. Now, on this table now, getting your grand total now requires summing all this up, all this up to get your grand total. So let's start summing them one after the other. I've summed this all up now, and I got 432 as my summation. Here I got 510 as my summation. Here I got 456 as my summation. And I got the last one, 372 as my summation. Don't forget, if it is given to you in this way, you're going to sum them all up like this. But if it is given like this in this rule, you follow it this way. But as it's given to us like this, that's why we sum all of them all up like this, and all of this like this, all of this like this. Now, plussing this and this and this and this together will give us our grand total. Alright, in which, if you add them all up, you see your grand total will be 1,770 as our grand total. Right? That is our grand total. Now, going back to the next page to look for our common factor, in which the formula used to look for our common factor, we say, here we say equals to, common factor equals to grand total raised to power 2 divided by n. Right? Grand total raised to power 2 divided by n. What is our grand total? Our grand total now is equals to 1,770 raised to power 2 divided by the total number of rows, the total number of variants given to us. Let's count carefully. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So our total number is 24. So we are dividing the grand total divided by the total number. So let's go back and do that. Now, divided by 24 is equals to, the total answer right here I got is 130,537.5. So that is for our common factor. Now we got our common factor in constant. So let's move to the sum of square treatment. Don't forget, first things first, sum of square total, you have to carefully calculate your sum of square total before going further to the sum of square treatment. So let's go. Okay, after getting the grand total, which is the common factor, which is to be 134,192 minus this 130,537.5 equals to, the total answer here we are having 3654.5. Okay, that is all for sum of square total. Okay, now I'll be bringing another fresh slip to use. So we'll keep this aside, but we're still using it, right? We'll still bring everything back in place. Okay, now we are going for our sum of square treatment. SSTR equals 2. Don't forget the formula. Summation of this, x, it is a constant formula, minus common factor. Okay, this y, it is y right here, y, not x. It is for sum of square total that it's carrying x. Then this is saying all over number, right? So let's go. Summation y raised to the power 2 equals 2. Is equals to this. So let me bring the formal calculation so I show you carefully on how you're going to go about this. Yes. Now, to get our sum of square treatment, we will square this all up. We'll square this up, square this, and also square this. That is for this formula, right? So let's start by squaring all of them up. So I will keep this aside. But don't forget your first calculation. You have to go back to this first calculation to get the total number of row on the first column, the second column, the third column, the fourth column. So let's go. Now, on the first column, we have 432 raised to power 2 divided by the row. So I'll take you carefully. I'll go back now and show you the row, the number of rows in the question given. So let's go. Now it's back again. Now the total number of rows in the first column is 1, 2, 3, 4, 5, and 6. That is the total number of rows. So it will now be divided by the total number of rows. The total number of rows, which is 6, plus next row, we have 510 raised to power 2 divided by the same 6 because it's 6 in each row. Then we'll add it up again and say the next row, the third row, which we're having 456 divided by 6. And the fourth row, you add it up again and say 372 divided by 6. You are squaring them all up, don't forget. Squaring them all up and divide on them. So after the whole square now, I got my answers, and my answer is equals to, the first row says 186,624 divided by 6. After squaring this up, I got 186,624. Then plus the next one, we have 260,100 divided by 6 plus the next square says 20,793 divided by 6 plus the last row, which is the fourth row, says 138,384 divided by 6. After doing this, then you now divide by 6, by 6, by 6, by 6, and by 6. You now say equals to, the first one says 31,104 plus 43,350 plus 34,656 plus 23,064, right? So sum all of them up and get your final answer for the sum of square treatment in order to carry out the computation, which will be moving forward. Now, after summing all this up, we got 132,174. Now, don't forget your formula, which says the summation of this raised to power 2, the summation of this minus common factor, in which we've gotten our common factor as the constant figure in the previous lecture. So the answer we've gotten right here is what we're going to continue now after summing this up. We say 132,174 minus this common factor, and in which we have solved our common factor in our previous in this previous paper, which I'll be bringing back and showing our grand total, which is our common factor, which we have 130,537.5. So let's put this down right here. We say here now, which we have squared and divide them by 6, right here, and divide them by 6. Then we get this figure. When summing all of them up, we got this figure. Now, don't forget the formula, in which you have to minus the common factor too. Now we did already here, we minus the common factor, which gives us this figure. Now, the last one now is the sum of square error, in which the sum of square error is SST minus SSTR. SST is equals to, we have SST as 365.5 minus SSTR, which the SSTR is here. We're having 1636.5. The answer is equals to 2,018. This is the answer for the sum of square error. Now, after calculating all this from the beginning to the ending, you now put them in your ANOVA table, which we are already filled up with this sheet right here. And the next now is to take another sheet and make our ANOVA table, and we are done for the day. So let's go. I'm bringing in another sheet and keeping this aside. Now, all the results we have gotten now should be on our ANOVA table, which we are placing the table. Don't forget, you must use this table. Now, source of variation. Direct factors. SS, sum of square, don't forget. Mean of square. Then the F value, which has been our previous, the Folocom formula. Now, here we're having the treatment, sum of square treatment. Sum of square treatment. Don't forget that formula that said R minus 1, R minus 1, which is equals to 3 minus 1 equals to, which is 4 minus 1, I mean, the rho minus 1, which is equals to 3, right? And the figure we got for sum of square treatment is 1,636. The answer we got, the last figure we got. Then we move further and go to sum of square error. We say error, don't forget this, always do this on your table, because it is a table, so it will be shown clearly. Now for error, we say number minus rule, n minus r, equals to 24 minus 4 equals to 20. So, and the sum of square error is 2,018. That's the sum of square error. And now we rule this, right? Okay, let's go further. And as we proceed, we all will still go more better in this. Now for the total, which is number minus 1 equals to 24 minus 1 equals to 23. Now the sum of square error is 3,000, and total, sum of square total, sorry, is 3,654, which is the sum of square total. Now, to get your mean of square, now you say source of sum of square divided by direct factor, which is going to be this divided by this, right? We are saying 1636 divided by 3, which the answer is equals to 545.3. The same thing apply here. Sum of square divided by direct factor, which is 2018 divided by 20 equals to 100.9. That's for our mean of square. Now for the f value, we said mean of square mean of square total treatment divided by mean of square error. So which is going to be 545.3 divided by 100.9. Now this is going to be testing the 5% level if it is to be tackled with or accepted or rejected. So dividing these two together now, we now get our answer as equals to 5.4. Yes, it is to be accepted. The F calculated is accepted. Now our F statistic is equals to 5.4, and that is all for the day. So thank you guys. Alright guys, hope you enjoyed my lecture on this ANOVA table. If you do like content like this, I'd like you to click to the subscribe button and notification icon and get notified whenever I post any video right here on this channel. See you guys next week. Bye.